Hydrostatic force on curved surface. For hydrostatic force on curved surface, we have difficulties of force distribution that act on the curved surface. They are not act on the same direction. They also have different value. However, we could calculate the resultant force by using component forces, which is we call it as horizontal and vertical force. Please be careful about each equation. They have slightly different in definition. So this is the example of curved surface. As you could see here, we have a curved surface which is semicircular shape here. So and then we have a fixed wall here, stay in vertical, and this is the bed of this pool. And we have a water here. Because we have water here, for sure we have pressure. And then from this pressure, it will act to the surface, so and then it will create force. And then to draw a force on a curved surface here, you need to draw from the liquid to the surface. For example, if we want to draw a surface on this brick wall, so we could draw a straight arrow perpendicular to the surface like this. However, to draw an arrow to show the force that acts on the curved surface, you need to draw like this at this point, because this is the perpendicular direction. So and then the force that acts on this point, we could draw it like this one, because it must be perpendicular to the surface. And then if we want to draw a force that acts on the surface, we need to draw like this, because it is to make sure that the drawing of the force, the vector of the force, is perpendicular to the surface. And then we could draw another force like this one. And then because we have a lot of force with different magnitude, because the different depth here will give us different value of pressure, and then it will give different value of force. So and then the direction also different to all forces that act on this curved surface. So and then, because we have so many forces here, we will conclude that there is one effective force that acts on this curved surface. So we call this effective force as the resultant force that acts on this curved surface. As I said in previous lecture, so to calculate the force that acts on curved surface, we need to split them into horizontal and vertical force. So to prove that that method can be used correctly, so in this slide, I would like to show you the calculation of force on surface by splitting them to horizontal and vertical force. For example, we have a plane surface like this, and the location is inclined at certain angle like this one. So let's say the length of this one is 5 meters. So and then we put it in the location with the horizontal length here is 3 and the vertical length is 4. So and then we mark the centroid here. Okay, so this is the centroid for the body, for the plate. So and then to calculate the HC later on, it is 4 divided by 2. So we draw a 2 meter depth here. So let's say this plate has a width of 2 meter. So and then the resultant force will act a little bit lower from the centroid point here. So we draw an arrow like this perpendicular to the surface, and we denoted as FR. So we could calculate the resultant force from our previous calculation as rho g HCA. So here the HC is 2 and the area is 5 times 2. So the length of here is 5 meter. So the width is 2. So that's why the area will become 5 times 2, and then we could get it is equal to rho g 20. And then we could calculate the value of YR by using this equation. So we could get it is equal to 3.33 meters. And then we try to prove here we could get the same amount of resultant force by splitting them into horizontal and vertical force. Okay, let's say we start with the horizontal force here. So I think everybody here is known that the resultant force will act like this one, and then we could split them into each component of horizontal force like this one and vertical force like this one. Okay, this is the free body diagram to show the vertical force and the horizontal force. So the horizontal force will act horizontal like this, and the vertical force will act like this one. So and then to calculate the horizontal force, okay, to calculate the horizontal force, we could use the same equation here, rho g HCA, but the area here, they need to be changed because the horizontal force is act horizontal like this one. So means that we need to use the idea of projection area. So projection area means that the shadow of the inclined surface here. For example, if you have a source light, a torchlight here, so the shadow of this inclined plane will stay in vertical position here. Now, so we call this one as projection area. So because we need to make sure that the force here acts perpendicular to the surface, so we change the object here from inclined position into a straight a vertical position here. However, the location of centroid is remain the same, which is here, which is it is 2 meters from the free surface here. So we could calculate the horizontal force. We substitute the HC is equal to 2. The area is now become the vertical plane. So it will become 4 times 2. And we could get the horizontal force is rho g 16. So and then we could calculate the YR. According to this equation, we get it is 2.667 meters. In this situation, we need to use a projection area as an A. So please be careful here in your calculation. And then the submerged area will become 4 times 2. And then the vertical force can be calculated by using the idea of rho GV. So the V here is the volume. Okay, and then we could calculate the volume for this one, means the volume of this area by using a simple equation which is equal to this one. So and then you could get it is equal to rho G12. So this vertical force acts through the centroid of the volume of water. And then we need to calculate the resultant force by using simple math equation. We could calculate the resultant force as this one. So it is equal to FR rho G20. So this answer is same with the answer obtained from the first method. It is mean that by using component forces, we could calculate the resultant force. So as a conclusion for this method, to calculate the magnitude of the resultant force on curved surface, we could use these two equations. First, you need to calculate the horizontal force, which is the rho GHCA, but you need to understand the area here is the area of the projection area. And the equation for FV equal rho GV here, the volume here is the volume of liquid above the curved surface. So, and then we have a discussion about the volume of the above the curved surface. So for example, if you have a brick like this one, so you have a fixed brick like this, so and then you have a curved surface like this one, and then the water fill until this level. So means that even though there are no water volume here, okay, to calculate the volume here, you still need to calculate all the volume above the curved surface here, whether the liquid exists or not. Okay, means that I explain again. If we have a design like this one, for example, so you have a water here, so the in real situation, the water only fill into this area. But when you calculate the vertical force, you need to use the equation of rho GV, and the V here is the volume above the curved surface. What you need to calculate is the volume above the curved surface. So you need to calculate all this area and substitute into this equation. Okay, please be careful when you make decision what volume that you need to calculate and substitute into the equation. So this is the equation to calculate the resultant force, and the YR here is the location of the resultant force on curved surface. It can be determined by calculation but depend on the curved surface shape.